Alright, number 3 here, we have a table and we're asked to determine whether the given function is linear or nonlinear, and then if it's linear, determine the slope. Okay, so I'm just going to copy this table down, and you'll get the visual, kind of like what you saw in the text. We have 1, 2, 3, how many points here? 1, 2, 3, 4, 5. We don't have to use every single one of them, but the more thorough you are, the better. Negative 27, negative 22, negative 17, negative 12, and negative 7. Okay, so what we're going to be doing is finding the difference in the x's all the way down the table and the difference in the y's. It is very important to note what the x's are counting by. They're counting by 1s. You always want to subtract bigger from smaller. So if I do 2 minus 1, gives me a difference of 1. 3 minus 2 gives me a difference of 1. So each of these, you can see there's a difference of 1. So that is a constant change in the x. We should see the same, not the same as the number 1, but whatever number is the difference, we should see the same going down here. That would indicate that the function is linear. So here, I would be doing a negative 12 minus a negative 7. Minus a negative turns plus positive. So 12, negative 12 minus 7, really, plus 7. We actually subtract, gives you a negative 5. Okay, so we subtracted 5 going from here. And then the difference between negative 12 and 17 is also a negative 5. And then from 17 to 22, negative 5, and negative 22 to negative 27 is also negative 5. So if the x is the same and the y is the same all the way down, then you can tell it's linear. Now there are instances where x may not be counting by 1, and we will have to look at the ratio of the differences. And what I mean by that is you would take the difference in these first two and put it over below the difference of the second two. So remember, slope is change in y over change in x. Okay, so y goes on top. So part of this, we have a negative 5 on top and a 1 on the bottom. So that would give us a negative 5. And you can do that all the way down, and you see you get the same. So this is our slope, which is also part of this question. They wanted us to find the slope, and they wanted us to determine if it has an average rate of change. So slope is negative 5, the rate of change is negative 5. It's consistent all the way throughout the table. So is the function linear? Yes. Now that we know it's linear, what is the slope? And we have computed that with change in y over x, which just gives us negative 5.